Alright guys, for notes 4a.5, we are actually going to learn 3 things. A couple of them we've kind of seen before. The first one we're going to talk about is your triangle proportionality theorem. There are no blanks to fill in here, but it says if a line parallel to one side of a triangle intersects other 2 sides, then it divides the 2 sides proportionally, and the converse is true. Okay? So what this is going to mean is that if segment AB right here is parallel to segment CD, here's our conditional statement, if then the ratio of AC to CE, so AC to CE, is equal to the ratio of BD to DE. BD to DE. Okay? So we're going to have some parallel sides. You're going to have to see that these are parallel. Alright? So we'll take a look at that example here. Or a couple examples. So what we need to do is we are now going to start going back to the proportions, the second part of the first day's notes, where we set up proportions and we solve for the missing part. What's great about the way this looks is we actually already have our proportion. We could draw fraction bar here equals fraction bar. So we can take the 33 here, it's just the part right here, to this part over x, is equal to this part 27 over this part 18, because we have these parallel lines. Okay? So again, reminding what we do with proportions, we're going to cross multiply here, and we're going to get 27x. We set that equal to 33 times 18. I know you want to get your calculators out and do it all on your own, it's fine. We're going to come up with 594. Last step, divide both sides by 27. 594 divided by 27 is going to give you 22. So this is going to be that missing side right there. That is all the triangle proportionality theorem is. Now sometimes you will wind up with a problem like this, where we're given this whole side. We just want this piece. We want to set this to this and this to this. You can also set this part to the whole side and this 12 to this whole side by adding these 2 together. What I'm going to show you is going back over here so you guys can see if I want to set this part to this part, this part to this part. Okay? What's going to happen here is if we set 12 over 4 ratio of 12 to 4, we would want to set this as x, because it corresponds with 12, so it needs to go on top, x over we just want this part. This is going to be the whole 20 minus this x. So it would actually be 20 minus x. I am going to write in here the other way that I was talking about. You could still do your 12 to 4. Sorry, actually, let me redo that. We can do our 12, this part, no, that was right, to the whole thing of 12 plus 4, 16. Set that equal to the x corresponds with the 12, x over the whole thing of 20. Either way, if you do your math correctly, you will come out to the correct same answer. I am going to be working this one out. That way we practice our distribution here. Okay? So here, I'm going to multiply these 2 together. 12 on the outside, giving me 20 minus x on the inside. Set that equal to 4 times x, 4x. I'm going to then do my distribution. 12 times 20 is going to give me 240. I'm going to subtract, because we now have a negative x. 12 times a negative x gives me a negative 12x. Set that equal to nothing to do over here, just bring him down. Now we start solving. I notice on the left I have a negative 12x, so I'm going to bring that guy over to this side, okay, by adding 12x to both sides. These cancel. Bring down my 240. We add 12 plus 4. We're going to wind up with 16x. Last step, divide both sides by 16. X will come out to 240 divided by 16 is 15. So we have now solved for x. Okay? There is also a way to check. I want to come back over here, and even though it's not required, I want to go ahead and show you guys how you can check. If you have found out that x is 22, I'm going to plug that in here. Okay? What we can do is we can set up the ratios exactly like this, but instead of x we put 22, cross multiply and see if we get the same thing on both sides. This is what I mean by that. We have our 33 over, instead of x, we found out it was 22. This is how you can tell if you're ever asked, are these two sides parallel? This is what you would do. I would give you all 4 of these. And you'd say this part over this part, which is what I have right here, is equal to this part over this part, 27 over 18. You will then cross multiply, okay? So your 33 times 18, we actually already discovered over here, was going to be 594. See if that is equal to, when we cross multiply 27 times 22, you're going to get 594. So we could check off and say, number 1, I did my problem correctly. This is the answer. Or if I ask you, are these parallel? We can do this to figure it out. We wouldn't be missing a side. I'd give you, or missing a part, I'd give you all 4 parts. Okay? Triangle proportionality theorem. Are our little parts proportional? The next is going to be your parallel lines and transversals proportionality theorem. It's actually almost exactly like this. It's going to be a part over a part equals a part over a part. All right? But this time we have parallel sides in our transversals. So on this part, we would state that if line, because you see the lines at the ends, okay? If line AD, right here, is parallel to line BE and is also parallel to line CF, then we can conclude over here that the length of AB over the length of, we can either go BC or we can come over here D. I like to do it this way. Well, we'll go ahead and do BC, the way it's pictured. Should be equal to the ratio of the length of DE to the length of EF. Okay? And again, if I give you numbers for these parts, you can set it up like this, cross multiply like what we just did on the triangle proportionality theorem, and see if the lines will be parallel. Okay, but you have to have at least 3 parallel lines. So let's take a look at our examples here. So how we had it is we had 2 different sides here. Okay, so we've got this transversal right here, and we have this transversal right here. So we can set up this part to this part. So we've got our x over 12.5. We set that equal to the ratio of the other ones, 12 to 15. Okay? Then we do our cross multiplication. 15x is equal to 12.5 times 12 is going to give you 150. Divide both sides by 15. Should be pretty good at proportions now. X is going to equal 10. Okay? And again, you can check yourself. Or if I ask you, are these three lines parallel? We now know that this is 10. So we can set it up as, instead of x, now we have 10. 10 over 12.5. Sure it's a point there. Equal to 12 over 15. So when we cross multiply 10 times 15, we get 150. And then when we cross multiply this, we already found out that was 150. So we could say either yes, I did my problem correctly, or if I didn't put x, I put 10 instead, you would say yes, these are parallel. So this right here is also doing the converse, proving that the lines are parallel. Right? The next one over here, we can look at this side, and or transversal, should I say, and this transversal. So we put the 27 over 18. Come back over here to my equal sign. X plus 10 over x. Okay? Keep in mind, these two are on the top, I'm leaving them on the top. These two are on the bottom, I'm leaving them on the bottom. So unlike this one you could honestly, you could do x over 12 equals 12.5 over 15 as well. There are so many different ways to set up your proportions. Okay? This right here, you know, you got your fraction bar here equals fraction bar. That's what we see here. So we're going to go ahead and do our cross multiplication. Here we have 27x is equal to 18 on the outside, x plus 10 on the inside. And when we distribute, we'll bring down our 27x and distribute the 18 to x. 18 times x is 18x. And then we distribute 18 times a positive 10, giving us plus 180. Right? So we need to now move one of our variables and coefficients. 18x is smaller, so I want to move him. Subtract 18x from both sides. We're going to wind up with a 9x left over. Bring down your 180. Divide each side by 9. And we'll wind up, x is going to equal 20. And I don't really have any room over here to show you the checking, but you can do the same thing over here. All right? The last one we talk about here is going to be our triangle angle bisector theorem. So we're going to be looking at, are we bisecting an angle here? All right. So our conditional statement, we have if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So all of this wrapped up in an if-then statement that we can maybe understand a little bit more would be if segment BD, this guy right here, right? If segment BD bisects angle ABC, that's what this, if a ray bisects an angle of a triangle, that's that part. Then, to clarify what all these words said, it's stating that the ratio of these guys down here, we're going to be proportional. So we can state, then, the length of AD right here to DC right here should be equal to the ratio of AB to CB over here. Okay? So that's bothering me a little bit. All right. So let's take a look. So here, we can either set this over this as equal to this over this, or if we want to follow along with what the front said, this over this is equal to this over this. Okay, it doesn't matter which way, because again, as long as you're cross multiplying the same things. Okay, so I'll do one of each. Okay, we'll do one of each. Here, we'll first do what the front said, the opposite side here. We're going to set that ratio up to this ratio right here. Okay? So I'm going to take the 8 over the 10 and set that equal to, now we've got to make sure the 8 and the x go together. So if the 8 was on top, the x has to go on top of the other one. X over 10 was on bottom, 12 is on bottom because it's part of the same little triangle here. Okay, it's a consecutive side right here. So we'll do 12.5. Do the same old thing we've been doing. Cross multiply. 10 times x gives us 10x equals 8 times 12.5 is going to give us 100. A lot of us could probably do this division in our head. Divide each side by 10. Here, remember that we can also cancel out zeros. A little trick. So 10 divided by 1. Or 100 divided by 10. Find out that x is going to equal 10. Okay? So I'm going to leave this one in view while I color this one because I want you guys to see what's going to change here, because you have a lot of different options. So here I took the side opposite of the bisected angle and colored it the same color and put it as a ratio. And then I took kind of like the little hat, or the little top, the roof here, and set it up. Now what I'm going to do is I'm going to set these up as a ratio rather than this. And I'm going to set up this as a ratio. Alright? And either way, if you decide to set this as a ratio and this as a ratio instead, you'll be cross multiplying the same thing. Okay? Let's see. We're going to do over here 10 over x. We're going to set that equal to, now the 10 connected with that angle bisector, so the 20 is going to correspond. Then we get 20 over this one right here of 15. Okay? So now with my cross multiplication, we're going to take 20 times x, get 20x, equals 10 times 15 is 150. Divide both sides by 20. 150 divided by 20 is going to give us 7.5. Okay? There's our answer. So it's all about proportions. It's all about the cross multiplying. And with these pictures, a lot of times, you pretty much already have your proportions set up, your ratios set up. This to this to this, with an equal sign in between. Okay? And that concludes this.